give it just a second as our participants start to roll in. Okay, my name is Aaron Smith, and I am the CEO of the Energy and Environmental Building Alliance. And I am especially pleased today to present the Pecha Kucha presentation with our Solar Decathlon Design Challenge winners. EBA has been a longtime partner of Solar Decathlon. Also, all proceeds raised through our EBA Next Gen Scholarship Fund go to support students attending the EBA Summit in person or this year virtually. And I think one really nice thing this year was that we were able to have all of the students that were able to attend the summit on a scholarship. So one of the nice benefits of virtual, of course, we'd rather all see them in person, and we look forward to doing that next year. So on behalf of myself and Nancy Bakeman and the rest of the team at EBA, I'd like to introduce today's host, Gene Myers. Gene is the CEO of Thrive Home Builders. He is the board president of EBA and actually is a longtime juror for the Solar Decathlon Challenge. So Gene, I'd love to turn it over to you, and thank you for being a host today.
Well, thanks, Aaron, and welcome everybody. Good morning or good afternoon, depending on where you are. I think we even had a team from China last year, so if any of those folks are watching, it's a good middle of the night. But it's really a great privilege to be able to introduce this session. I think I've been a juror on every one of what used to be called the Race to Zero, and now the Student Design Challenge for the Solar Decathlon. And it's really enriched my life to just be involved just for a few days with some of the really great, bright, young, passionate minds in the challenge. And so it's a really great treat to be able to present the best of that competition from last year. As Aaron said, we really enjoy a terrific collaboration with DOE all throughout the year, but especially during the design challenge. And it's been terrific to be able to participate as I have. And I wish that for everybody, that you would get a chance to meet these folks face-to-face someday. So Zach, I think, was my jury coordinator for the virtual version of the Solar Decathlon Design Challenge last year. And it actually happened during the lockdown. And so it was a very quick learning curve to take this from a live event up at NREL in Golden, Colorado, and flip the switch on the virtual event. And it did go down flawlessly. But so I know Zach from that time, and we had some job interviews with some of the participants, and it seemed like for the next couple of weeks, Zach and I were talking, and I told him at the end, I'm really going to miss you. So anyway, it's great to be able to introduce Zach. So Zach Peterson is a technical project manager in the Integrated Application Center's Strategy, Policy, and Implementation Group. The group leads complex energy projects that empower decision makers with the knowledge to adopt renewable energy and energy efficiency strategies by providing solutions to accelerate clean energy transitions. Zach's work focuses on grid modernization, distributed energy resource integration, and grid interactive buildings. And you know, one of the really fantastic parts of being in a high performance builder is the support we get from the national labs and from DOE. I think Zach's up at NREL still. And so what a great collaboration we've had. And Zach, it's a privilege to introduce you. And I think we're all in for an amazing treat. So I'll hand it off to you.
Yeah, thanks, Gene. And yeah, I mean, we love our partnership with you folks at EBA, and getting to see Eugene and the other jurors every year is quite a pleasure for us. And just seeing your guys' interaction with the students and everything really makes the whole event super special. So Well, we'll get to hearing their presentations in a little bit here. So welcome everybody to the Solar Decathlon Design Challenge Pecha Kucha session. And this is backed by popular demand from previous years. The Pecha Kucha, session hosts another impressive lineup of 2020 Design Challenge teams. And if you're not familiar with the Pecha Kucha, it is a bit different from other presentation styles. It's composed of 20 slides, each of which auto advances after 20 seconds. So each presentation is rapid fire, and the speakers don't have the ability to stop it, so things keep moving. And so after each session, there will be a 2-minute Q&A if you do have questions to answer these. We have quite a few of them, so this is gonna be a rapid fire session. And joining me for this presentation is my colleague, Amanda Kirkby. She is a fellow Solar Decathlon organizer. Hey, Amanda. As well as a previous Solar Decathlon participant. So we're excited to have her as part of the team. And before we get started, do people need to stop? Do you need to stand up? Do we need to do a quick stretch? Because this is gonna be, like I said, gonna be coming at you fast. So I think we are ready. I'm ready on my end, Amanda. So
okay, I'm ready too. Ready? Here we go.
all right, here we go. So what is the Solar Decathlon Design Challenge? Well, it is a collegiate competition comprising of the 10 contests you see here on the screen that challenges student teams to design highly efficient, innovative buildings powered by renewable energy. And each contest seen here covers an important aspect of zero energy design. So energy management and performance, as well as indoor environmental quality, are obviously critical components of the design aspect that all teams must master. But we're also excited to look at things like embodied environmental impact. So this looks at the life cycle of the building and how material choices for materials that are integrated into the building impact its life cycle carbon. So incorporation of building science training by leading industry experts helps students gain a strong foundation of high performance fundamentals and carry these throughout their design process and also into the workforce once they graduate. And this is required participation by all students. And the students really get to gain real world experience through the design challenge and work on multidisciplinary teams. So this typically includes engineers and architects, construction management students, business students, and they work together to do things like develop floor plans and design renderings and talk with clients about their needs and present their ideas. And industry partnership is a huge aspect of this. So we encourage all teams to work with a number of industry partners. This could be builders, this could be city officials, energy auditors, landscapers, all different types of people from industry who can help them and provide feedback and review their designs and help them improve their solutions. And this really helps to develop a cycle of career connections for the student teams and help them develop their professional networks. So not only with the students, but also the jurors. For instance, we can see Jean up there in the top right interacting with our students. We love to see that. And also at the bottom, we can see Nathan Carr, who is a previous participant who came back as a juror last year. So right about now, you might be wondering, oh, I'm an industry person. How do I get involved? How can I harness some of this student innovation? And how can I get connected with the student team to work on a project and explore zero energy design? Well, we're excited to announce that we're continuing our Design Partners program. And this is a unique form of industry partnership where an organization or a builder might have a planned or expected project in their portfolio, and they connect with the team and work with this team to define the design criteria and come up with a zero energy design alternative. And what's awesome about this project is it helps increase adoption of zero energy buildings because it helps reduce this fear of the unknown that some organizations or builders might have with developing a zero energy design and what goes into that and how much does it cost. And so there's a low risk opportunity. And so as a design partner, you get to explore these zero energy topics. You get to explore these designs. You get a design that shows you what are the lifetime, what are the utility bill costs? What are the lifetime energy consumption? How does this compare to something you typically see? And meanwhile, you are helping train the future generation of builders. So you might be thinking, well, what's the catch? There really isn't one. This isn't a huge lift for the design partner. We're asking for 20 to 30 hours of commitment over the competition period, which isn't a huge bit of effort, but to help the students really dial in on what you are looking for. And so, Amanda, how can folks get involved with this?
Yeah, so how it works is an organization interested in applying to become a design partner can go to solardecathlon.gov and find the design partner project application where they fill out project requirements and contact info that we can then share with the teams. Following that, the student design teams interested in collaborating with the design partner will reach out to you and with that contact information you provided and begin that initial connection and establish a partnership. Once that partnership is established, the design partner works with the student design team and meets with them over the next 4 months to go over iterations of the design, and the design partner attends design charrettes and provides review to the student design team as they go through the design process until the final competition event in April. And at the end of that design process in April, the student design team provides the design partner with a completed zero energy alternative design with design documents, financial analysis, energy performance analysis, and a full design package that the design partner can then compare to their current design for their project. So really, as Zach said, it's a win-win situation for everyone involved. It's the design partner gets a real world zero energy solution for a design project, and the student design team gets real world design experience in that client interaction that they wouldn't ordinarily get. A few examples from this past year's pilot program that we want to highlight are the Tippecanoe School Corporation partnered with Purdue University in Indiana, and they use this as an opportunity to explore new ideas to counter their increasing energy costs for their school. So it's a net zero elementary school. Another design partner that we want to highlight is the City of Alexandria in Virginia, and they partnered with the Washington Alexandria Architecture Center, and they use this as an opportunity to transform one of their historic buildings in downtown to support carbon and greenhouse gas emission reduction goals for the city. So both these highlight some awesome design partners that we had last year, and if you're interested, we encourage you to learn more about the design partner program at solardecathlon.gov, and you can find more information at that website, as well as some of the design partners that we've worked with in the past and we'll work with next year. And there are other ways to get involved. And so either become a design partner, recommend someone that you could get a design partnership going with. 1 second, we've got other ways to get involved and encouraging a team from your alma mater. We encourage you to reach out, and if you know any faculty that could encourage a student team to apply to the Solar Decathlon Design Challenge. If you know an industry professional that would be interested, as Jean mentioned, in becoming a juror, and this is a positive experience for everyone involved. As a student, we get a great experience interacting with industry professionals, and as Jean said, it's a great experience for them as well and inspiring. Spread the word on social media, and with that, these are a few ways we can get involved, and we're excited to showcase some of the winning designs from this past year Solar Decathlon Design Challenge. And so we'll move on to our first presentation, which is from Surreal Estate, and they are unable to attend because of the time difference. would have been 4 a.m. for them. So we're going to share a recorded video of their presentation. I'll bring that up real quick. And with that, Surreal Estate was the division winner of the suburban single family division for this past year design challenge. And their design employed strategies passive design strategies and married orientation with natural ventilation, as well as integrated fire resistant materials into their design. Without further ado, here's their design. Oops.
Hi, we're Surreal Estate and we'll be presenting to you our single suburban family home design from the Solar Decathlon last year. I'm Sarah and presenting with me today are Sandy and Shrishti. Our team is a multidisciplinary team that came together in 2019. We draw our knowledge and skill sets from a variety of disciplines, including architecture, civil, mechanical, and materials engineering, as well as science. We come from Monash University in Melbourne, Australia. As I'm sure you'll all remember, the Australian bushfires last summer were devastating, not only taking the lives of many, but also destroying over 2,000 homes. To address this, we wanted to create a bushfire resilient home that was affordable for young Australian families. So our main approach to making this net zero energy house affordable and accessible for these young Australian families was to implement various passive energy reduction strategies throughout the home, and we adapted it to be suitable for the local Australian climate. To do this, we took a holistic approach to our design, thinking about the before, during, and after a bushfire. So not only do we have preventative measures in place before a bushfire occurs, we also made sure that our house is resilient during and after a bushfire. So some examples of preventative strategies include a 15-feet fire break that keeps the house away from high energy sources, as well as a gutter guard that minimizes the accumulation of debris in the gutter that can cause the roof of the house to catch on fire. If these preventative measures are breached and the house does catch on fire, we want to minimize the fire spread and fire intensity as much as possible. This is why we have most of our house constructed from spotted gum timber. It's a native eucalyptus tree that can survive bushfires because it takes so much longer for the fire to penetrate and spread than other common species of timber. So not only do we want to minimize damage to the house, we want to prioritize occupant safety. This is why we have things such as an external sprinkler system and large casement windows for the occupants to safely escape. Now, let's consider the aftermath of a bushfire. Even though the house may be damaged, another reason why we chose spotted gum timber for a bushfire resilient house is that it's much easier to reconstruct and restore a timber structure compared to other sustainable materials, as ironic as it may seem that we're using wood for bushfire resilience. Another concern is the water shortages that are likely to follow a bushfire, which was the case last year. That's why we have our 1,800 gallon rainwater tank, which is not only a staple in Australian backyards, it will allow the occupants to go off-grid for 2 to 3 weeks. Now I'll pass it on to Sandy.
Thanks, Sarah. So we wanted to know how much a bushfire-resistant home would cost the average new Australian family. Melbourne's housing market is ranked as one of the most severely unaffordable in the world, and this is based on the house price to income ratio. It can be roughly compared to the house market in Santa Cruz, and this makes affordability all the more important. We designed this house for the suburb of Tarneit in Melbourne, Australia. A review by The Australian estimated that Tarneit was one of the suburbs tipped to experience above average growth in the next 12 months. We chose Tarneit because it is predicted to be 15% more affordable than inner city Melbourne. This makes it perfect for our particular demographic. The total construction costs are approximately $196,000, and this is just over the lowest bracket cost to build a home in Victoria. The average home in Tiny costs approximately $277,000. We believe this is a conservative estimate and suitable for the mean household income in this area. Now I'll pass you over to Shrishti to discuss our sustainable strategies.
Thanks, Sandy. The materials chosen were compared for their architectural properties, overall cost, recyclability, and most importantly, fire resistance. We chose to ensure that all the materials were locally sourced to support Australian businesses and to reduce energy costs. The materials were then meticulously refined to veto non-renewable materials and minimize embodied energy. By including a vegetable garden and a water tank, we encourage agricultural education and a self-sustaining lifestyle. Additionally, the water tank was situated in close proximity to our water heating system and our utilities for easy everyday use of reclaimed water. One innovation that our team decided to use was the introduction of an app. This app gamified water usage and energy conservation, thereby creating a family-friendly way to promote a more resource-conservative lifestyle. While the features of the house were important in maintaining sustainability, the inherent design optimized the use of natural resources for passive energy reduction. One passive energy reduction strategy was to maximize thermal energy from the sun by utilizing the north-facing side, as this side gains the most sunlight in the southern hemisphere. Placing larger windows on the northern front optimized passive heating from the low-lying sun in Australia's cold winter months. This also minimized sunlight penetration during the summer. By also including pathways for plenty of cross-ventilation, we further mitigated the retention of heat on Australia's hot and dry summer months, thus allowing families to enjoy a cool and comfortable internal temperature range without excessive use of the air conditioning system. Additionally, we chose to implement thermal zoning as a feature to help conserve energy. Each room was designed to ensure that only the spaces that were being occupied were being air-conditioned or actively heated. This removed the issue of wasted energy, wasted heat, and wasted cooling. Another strategy that we implemented was to ensure that all of our water utilities were centralized as much as possible. This further minimized energy loss from hot water traveling through plumbing, heat loss also minimized from hot water traveling through our plumbing, and thereby reduced the amount of materials required for the construction of internal water systems of the house. In conclusion, we have designed a resilient home for young Australian families, one with net zero energy, affordable pricing, and necessary fire resistance for an ever-changing Australian climate. Thank you so much for having us.
Hi, we're Surreal.
Wow, what a presentation. That was awesome. Thanks to the Surreal Estate team. As we said, fortunately, they're not around to answer questions at this moment. They're probably all in their beds and sleeping right now. But if folks do have questions out there, we would love to connect you with them or send those to them and close the loop on that. But we will keep moving here on to the division winner in the mixed use multifamily division, the University of Arizona. So this was Team Sunblock with the University of Arizona, and their design on the loop delivered a realistic design portfolio and honored the Southwestern vernacular. Ellie Franzen and Rachel Schultz will be presenting their team's design, the loop. Ellie and Rachel, are you all ready?
Hi there, can you guys enable our video?
Yeah, I'm sure someone's working on that in the back end here.
I can do that.
We can hear you all right.
Okay, now there we go. Perfect.
There we go. Yep. So we have the slides up. Are you guys ready? Oh,
We are ready. Yes.
okay, there you go. All right.
Okay. Hi, I'm Ellie Franzen. And I'm Rachel Schultz. We're excited to share our project Sunblock at the Loop with you. This project was our first attempt at creating a mixed-use multi-family housing development that helps sustain its neighborhoods by providing solar energy, community spaces, and social resources. Our hometown is Tucson, Arizona, 2 hours south of Phoenix. The site we chose represents familiar challenges faced by American cities suffering from increased urban sprawl, a lack of walkability, and a lack of public infrastructure. Our site was originally home to a vacant strip mall resting on 250,000 square feet of asphalt. The surrounding Myers neighborhood is a diverse and vibrant community with Myers Elementary School and Freedom Park as some of its only community resources. Made up of 396 low-income homes, families in the Myers earned 43% of the United States average median income. These homes, resources, and our site are connected by utility easements. We approached this project with an understanding of Tucson's unsustainable growth pattern shown on the diagram in the left, which allowed us to see where we can make efficient changes and redirect Tucson and other urban city centers. These categories have a unique and important relationship with each other, coming together to create a system where each component plays a role in the project. By viewing each category as a part of a whole picture, we can maximize the benefits of individual elements and create a better whole. In combination with the district energy system, Sunblock, this project is proposing an innovative growth template for low-density cities and suburbs. The proposed template encourages builders to design locally, taking advantage of material, thermal, and environmental processes already present. The loop is successful thanks to a set of goals that prioritize sustainability and community among its residents internally, as well as the surrounding Myers neighborhood externally. Our goals coming into the project manifested themselves in a retrofit of the existing strip mall alongside a new build, both performing at FIAS 2018 plus standards. The Sunblock District Energy System proposes using the excess solar energy produced during the middle of the day to heat or chill water that is then stored and used to condition the Myers neighborhood. By producing enough solar energy with on-site PV arrays shown in yellow, we can cleanly condition the entire Myers neighborhood.
To maximize energy use efficiency when conditioning with cost-effective balanced ventilation, creative solutions are utilized in both residential and commercial spaces. In the office, supply ducts run under a raised platform and air is exhausted near the ceiling, creating a natural convection loop. In total, the loop offers 89 units consisting of 88 studios as well as 2 and 3 bedroom units. These are centered around our daycare and community resources. The right side of the lot offers public resources to the surrounding neighborhood, including an agrivoltaic urban farm, bus stop, library, retail, and office space. The new build celebrates passive natural ventilation with recycled metal solar chimneys serving residential units on the southwest facade. These chimneys reference the local tradition of using rusted metals while also taking advantage of its recyclability and resilience. This language is continued down the south facade with shaded patio spaces clad in recycled metal and native vines. The loop offers community resources on site, such as an office, retail space, daycare, and public library. These resources connect residents to their city by improving public transportation in a car-dependent urban setting. This is accomplished through an electric car rideshare, a new crosswalk, a reimagined bus stop that includes a community garden, an extensive bike path designed from existing utility easements. The loop focuses on the Myers community while also acknowledging Tucson's need for affordable housing. Our rent reduction program allows us to cater to 3 often overlooked demographics, including single-parent households, the elderly, and Tucson residents who can no longer afford the rising cost of housing. Blurring the lines between indoors and out helps us understand how the outdoor environment can reduce our energy usage while also providing a pleasant place to live. Lush bioswales and solar chimneys strategically placed on site work together to create a comfortable environment. Within each unit, design choices like VOC-free and natural building materials, natural daylight, and balanced ventilation, along with natural ventilation, come together to create a comfortable indoor environment for residents. To reduce thermal bridging in the existing foundation, creative solutions such as an insulated bench to the left and a curb cut to the right were employed. Operations are an essential part of the Loop's success as a unified community. It's where the Loop fosters a relationship with our residents. Our In the Loop app is a tool to empower residents with comprehensive data about energy use and indoor air quality. With this data, the Loop can become a tool for the future of sustainable design. The Loop is financially feasible and affordable. A unique ownership profile puts residents in charge of the Loop, keeping financials focused on their goals and putting those motivated to develop the Loop in a place of leadership. Monthly utility rates are low thanks to Sunblock, which averages only $100 a month for gas and electricity. Resilience is exemplified through climate-based material choices and landscaping that reduces common floods in Tucson and pollutants while recharging the water table. By utilizing WUFI energy modeling, we can produce Sunblock allows the Loop to constantly provide a comfortable environment even in the event of a blackout or grid failure. Through WUFI and theoretical climate data, the Loop is preparing for climate change 60 years into the future, confirming the Loop will always be running at FIAS Plus 2018 standards. In addition to this, the use of airtight units and balanced ventilation ensure clean air for each resident, reducing the risk of community outbreaks during pandemics. By understanding that no one component will be at its best individually, the Loop aims to empower the individual, create an influence in the community, demonstrate a positive change, and finally become not only Tucson's new growth pattern, but a template for sustainable growth in cities around the world. Thank you. Thank you.
Great work. Yeah, it's just really awesome to see your guys' energy and enthusiasm has been here since the design challenge. Great work, guys.
We're so excited about it.
So, question from the audience here. So what do you think about your method and approach to this project that resulted in you guys winning your division?
So we feel like one of the things that really made us stand out when approaching this project was our
our really holistic like systems thinking. We started way zoomed out with those like feedback loops, and we were thinking really big picture, like what about people's lifestyles right now is like not encouraging them to live sustainably, and what can we put in a building that is going to facilitate a whole new lifestyle.
Yeah, it was our enthusiasm for the idea that you can take the idea of systems thinking, which is a natural science sort of theory of how natural systems in the world works, and apply it to every single aspect of architecture and every single aspect of high performance design, and understanding that even the like output of like hot air from some kind of mechanical system can be used somewhere in a way that is efficient. So trying to understand each element as a whole really helped us approach this project. And then also just having amazing mentors, our professor Jonathan Bean, and then
Jonathan Bean helped facilitate in our studio a group of projects that made up the Sunblock system. So we were working alongside a few other projects that were in other divisions in Solar Decathlon, and we designed for the same neighborhood, and we designed a neighborhood that was sharing energy and working together. And thanks to Jonathan Bean, we have received a ton of passive house consultant training. We're actually on our way to get our CPHC certification right now. So we used FIAS throughout the whole thing.
Yeah, that's fantastic. Well, thank you so much. I think we have to keep things moving here. I know we could sit here and talk all day. So we will move on to the next presentation. Thank you, Ellie and Rachel. Next up, we have the division winner from the office building division. So Team River Heights from Illinois Institute of Technology. And I can see you guys are already here. So this team completed a robust energy analysis. They employed exposed mass timber in their design, and they brought a really creative flair to their division presentation, which was really awesome to see. And so looks like we have Pablo and Feng Yang on. Are you guys ready?
Yeah, hello, good afternoon, we're ready.
All right, looks like we have the slides up. So you give Amanda the word and she will start it.
Okay, before starting, I would like to thank my fellows in the team who are not today here, Nupor, Sergio, David, and Rafael, and also to our faculty lead, Eduarda Corradi, who has been essential. Okay, we are ready to start. So when deciding the project, we felt the responsibility to address one lead issue of our city. We realized how Chicago's skyline is changing in the next few years, with new towers which generally have high energy requirements and home construction based in steel, glass, and steel produce tons and tons of carbon dioxide. Therefore, we set our first goal, designing a zero energy tall office building as an example for the city. The building should also show that green buildings are marketable, so it should be attractive. And we also wanted it to have a low carbon footprint. So we worked with mass timber structure and wood-based envelope. In a first step, we focused on industrial areas along the Chicago River, intending to return these spaces to citizens. We located an area close to Chicago's financial district, the Loop, where there is a project currently being drafted by SCB architects, the River District. We contacted SCB and they gave us their permission and guide along the process. The plot where the master plan is located in the west bank of the Chicago River's north branch is surrounded by major streets with easy access to multiple metro, bus, and bike lines. The plan proposes a new section for the Chicago Riverwalk, a new street, a new plaza, providing green areas for residents. We performed some initial software analysis to provide some baselines to the architectural design. Our design requirements were the following: 30% window wall ratio and R40 envelope to reduce energy consumption, regular symmetrical shape for a right structural performance of the mass timber width, and implementing PV panels in facade to improve energy generation. Those analyses also gave us the first crucial design decisions. We tested different shapes and orientations using PV, Solar, and OpenStudio. We needed a square shape perfectly oriented to south. This position gives us a lower heat loss coefficient and increases the energy production. The shape and the window wall ratio, however, limit the natural light in the center of the building. We created a series of open public spaces to bring natural light in. Around the core, we placed an atrium and a 14-story atrium supported by 4 perimetral 3-story winter gardens that spiral up through the height of the building. This solution also allows cross ventilation. With this basic layout design, we had 2 issues to solve. First of all, the integration within SCB master plan. Our analysis had broken with the master plan's orientation, so we did 2 important moves. We changed the corners in floors 1 and 2, eliminating corners column, and we placed the public program and art gallery to the Riverwalk. Secondly, we had to integrate PV panels in an attractive facade. Our design decision was dividing every story in 4-foot strips and using each strip as either window, PV panel, or green light panel. Plans in the green wall completely changes the strong cold image of glass and PV materials and improve thermal performance. The 4 facades have important differences. South facade is divided horizontally as PV panels are tilted to sun to improve efficiency. East and west PV panels are tilted vertically, looking for a better exposure. Thus, the facades are divided vertically, and alignments can change every few stories. North facade has no PV nor green wall. The wall detail is composed by a double facade assembly which contains a sandwich panel of OSB, a continuous rigid stone wool board, a continuous water membrane, an air barrier, a composite cladding, and high-efficient double pane windows. The cladding is either finishing or a layer before the PV and the green panels. To sum up with the design, every general floor is composed from inside to the perimeter by the core with stairs, elevators, and systems, the atrium, a perimeter corridor, and 20 feet by 20 feet units with office program. This unit can be customized just changing the furniture layout and some light partitions. Now, my colleague Feng Yang will explain HVAC and the energy analysis.
Thank you, Pablo. The primary HVAC system takes advantage of the building's proximity to a river and consists of a water source heat pump, which uses the river as the main source. The loop goes from the 15th floor, which is capped entirely for mechanical purpose, and to the river to 10 feet depths to find constant water temperature during the year. And in extreme Chicago winter conditions, if the river freezes, the water source heat pump will become unusable. So in those conditions, the same heat produced inside the building will be exhausted through the atrium, and with the skylight closed, it will remain in the 15th floor, which is an air source heat pump will operate. The secondary HVAC system is a radiant ceiling, which acts individually in every 20 feet by 20 feet unit, coordinated with sensors in order to act according to each unit occupancy and needs. This system will be coordinated by the building engineer and can be limitedly regulated by their tenants. The on-site renewable energy comes from the PV panels and biomass. PV panels has been studied with PV soils, considering every different surface with its particularities, giving as a result a yearly production of 2.5 million kBTU, which means 16 kBTU per square foot. The biomass energy comes from a power tanner PT150 placed on the 15th floor. It will use wood pellets waste, which is particularly present in Illinois. The loading dock and the service elevator allow a good working flow. The power tanner will add up to 11 kBTU per square foot per year, some a target AUI of 27. So in the open studio model, we included the passive strategy, such as orientation, geometry, wind to wall ratio, a tight envelope, daylighting, and natural ventilation. We also included HVAC system. When compiling all passive and active strategies, the resulting EUI is 24 kBTU per square foot per year, lower than our target EUI. Finally, we were able to perform a life cycle analysis. We computed all the materials from mass timbers to steel, glass, and concrete in the LCA software. Our building emits 296 kilogram carbon dioxide per square foot per square meter per year, and is the letter C in our benchmark. So let's say if we have accomplished our goals, according to the software result, the vertical river office building is energy positive. Besides, mass timber construction considerably reduced the carbon footprint. As a designer, we do love it, and we know it's a subjective opinion, so we will let you judge by yourself. Thank you. It's been a pleasure.
Thank you.
Awesome. Thanks, guys. That was great. Fabulous presentation. I was just looking through some of the questions here we have for you. And so you guys talked about a pretty complex HVAC system you guys have for the building. Can you talk a little bit more about the ventilation in the building and how it might differ from the summer season to the winter season?
Great. Thank you. It's a good question. Due to its aim to be a net zero building, we want to take the advantage of natural ventilation as much as possible. The reality is that a city like Chicago has high temperature during summer, while negative degrees in wintertime. So we did several CFD simulations for a project to see if natural ventilation is feasible in all cities. After observing our results, like the temperature field distribution, the air velocity distribution, we made a ventilation schedule and cooperated with our architects that if the data from the sensors show the outdoor environment is proper, the skylight will open automatically. The air will go through the winter garden, the atrium, and then the skylight. So natural ventilation is applied. And during wintertime, the skylight will be closed to make sure nobody's frozen and only the mechanical system is operating. Yeah, thank you.
Awesome. So how many stories were proposed for was the building?
We took the maximum possible by the competition guidelines, which is 15 stories.
Okay. And did you guys look into the code in Chicago that would be allowed for timber?
Yeah, sure. But of course, a 15-story building is not allowed in Chicago. However, well, we thought that as we were in a competition and we are students, it was a great opportunity to explore this new technology and go with it. And we know that many architectural studios in Chicago are pretty interested in mass timber. SOM has a project, Perkins and Wills has another project for timber towers in Chicago. And it's just a matter of time that the city will open to this possibility.
Yeah, well, that's what we love to see. We love to see your guys' innovation and you guys pushing the envelope. So appreciate that.
Thank you.
Yeah, great work, guys. Thank you. So next up, we will go to the University of Oregon. So they are the division winners for the elementary school division and the grand winners for the commercial category. So congrats to them. Team Polaris from the University of Oregon with their design, the Little Dipper Elementary. So this team, they really integrated very strong architecture. They employed design as a learning tool throughout their building and implemented a strong, very strongly focused on the kids. So with us here, we have Catherine Marple and Garrett Lever will be presenting to you all today. And so are you guys ready?
Yep, I think so.
Yep.
All righty, well, just say the word and Amanda will get started and send that first slide going.
All right. Yeah, welcome to Little Dipper, everybody. I think we're ready to start the presentation. So I'm Garrett Lever.
And I'm Catherine. Little Dipper Elementary acts as an interactive climate exploratorium where complex global challenges are broken down into kid-sized interactive exercises. We are so excited to share this project with you and could not have done so without our professor, Ihab Ziadi, our team member, Danielle Valdez, and colleagues at the University of Oregon. Little Dipper Elementary is situated between Mexico and the United States in Tecate, California, where a hard line stretches almost 2,000 miles, dividing countries, cities, ecologies, and even families. In Tecate, a majority of students come daily over the border from Mexico to go to school in California. So climate change, border injustice, overconsumption, these seemingly incomprehensible issues humanity faces must be taught to children as they become the next stewards of the environment. But how can design teach children about global challenges? And how can the built environment help break down those big concepts?
School aims to do so by highlighting kid-sized interactive learning moments against a simplified neutral field. 5 main design objectives guide the project: integrated reciprocal energy systems, students playing an interactive role, thresholds reimagined as inhabitable opportunities, integrating playfulness, and redefining beauty as affordable, accessible, and contextual. These objectives guided our choices for smaller components, systems, and the simple architecture that became the field for colorful and playful interactive specimens. The school achieves a net EUI of -10 by minimizing conditioned space, utilizing passive systems, and a simplified construction methodology. Playful innovations, such as the stewardship wheel, allow students to adjust climate control systems by cycling through modes, with indicators letting them know about wind, temperature, sunlight, and noise. Regular student participation in daily maintenance and operations contributes to a lower overall cost.
Pods of 4 classrooms create micro-communities of students and staff. Accessibility and simplicity drive the design of the structural and mechanical systems. And following passive house principles combined with prefab wall assemblies, walls are designed to maximize thermal insulation and affordability. The classroom itself becomes a home base for intentional learning with its environmental systems integrated into the curriculum. Students in a cleanup station would greet the students as they arrive. Sliding storage panels push and pull to create customizable breakout spaces, and a ratio of solid versus glazed wall allow for plenty of pinup space as well as daylight. Radiant floor slabs make the classroom cozy. In cooling mode, passive chilled beams cool rising hot air, and low windward supply vents sit above an evaporative cooling pond. An energy recovery ventilator would provide fresh air, and operable roof monitors would provide evenly distributed daylight and natural ventilation. Inside, the learning moments take form of interactive and functional objects. The desks would interlock with each other to allow more open space, while also being able to move around and keep supplies from spilling. The storage panels act as partitions as well as teachers of organization, and the picture windows would provide glimpses of fun activities happening outside. In the courtyard, adjacent classes of students share artwork on a panelized pinup wall, roll back the shading device, and play on the mound, gaze at the reflections in the cooling pond, and learn how to grow vegetables and herbs in the garden. This central courtyard also acts as a unique identifier for each classroom cluster.
Nestled within the classroom clusters, the community cluster serves as the prominent face and entry of the site. As students and faculty, as well as community members enter, the central core welcomes them to the gym, cafeteria, and library, which work together to serve as large collaborative spaces. These two buildings are meant to bring together students and community from both cities. In the community buildings, we wanted to reflect and elevate the industrial vernacular. Due to the dynamic program, these buildings utilize a standard high-efficiency HVAC system, coupled with well-insulated wall assemblies. Inside, students participate in the maintenance of their public spaces through interactive acoustic clouds and composting toilets. Outside, solar panels covering the south-facing roofs generate more energy than needed for building functions. Excess solar energy is sold back to the grid, while some send their unused energy to an on-site battery in the event of a power outage. These panels provide valuable renewable energy in a rather remote location. The Craft Center is a great place for students to paint and play, and the climbable pink mound provides a great place to read. In the library, students and staff interact with scattered blue bookshelves. In the gym, yellow sliding panels are pushed open and students prepare the elevated music room for a performance. With the help of RS Means, we estimate that Little Dipper Elementary would cost around $150 per square foot, meaning that this innovative school could be built for equal to or less than the average elementary school in the United States. We're able to achieve this figure by utilizing low-cost, durable industrial materials, which can be sourced locally and integrated with a prefabricated system. We imagine this prefabricated system as a catalog of parts, where clients are able to select from standardized classroom components like walls, windows, and roof elements. Add-ons such as pavilions with various infill panels provide customization. This system could allow for easy phasing of projects or future expansion.
The catalog intends to be a framework for quality design, but it's not meant to stand alone. Final finishes, climate-specific requirements, and labor must respond to site context and be sourced locally. This combination of prefabricated and site-specific elements makes Little Dipper Elementary a potential prototype for net zero primary schools. We want to leave you with the importance of optimism and play. The opportunity to design for future generations made us realize we don't have all the solutions, but thinking positively of the future kept us motivated. Turning awareness into hope is hard, but that's what architects, artists, and engineers are for, to keep solving and innovating even when all hope is lost, even when a student has to cross a militarized border to go to school. We have a responsibility to see the solutions, to stay aware, and to design spaces that encourage people to be actively engaged in their environment. Because when everyone is involved, the systems work. And when the systems work, it gives us the chance to play. Thank you.
Wow, thanks to both of you. That was fantastic. Continue to be impressed by this project. So a couple questions for you here. So your design team was pretty small, right? There's only 3 of you, if I'm not mistaken?
Yeah,
wow, that makes it even more. Go ahead, sorry.
I was gonna say we had 3 for the main project design, but then we had an additional support during the competition phase. So
okay,
it's so small.
So I mean, were there any like takeaways or anything, best practices advice you have from being successful with such a small team?
Yeah, we kind of have 5 like key takeaways, I guess. The first one is it was really important for us to establish this kit of parts from the very beginning. That was kind of that list of things at the beginning there. And that was really important for us to kind of establish this guideline that would guide us throughout every design decision, and would help us weed out all of the great advice and feedback we were getting from others. And so that kept us on like a really clear goal. And even when we were designing a part, we were on the same page about what the end result needed to be. So that was really, really critical. The second thing was kind of following a cyclical design process. So whether that was thinking about if we were looking at just the classroom itself or the whole cluster or the whole site, as well as looking at the systems or testing those systems, we were constantly going between those instead of just following a linear process. So that was also really important. And then Garrett's going to talk about our other thing.
Another takeaway was our collaborative workflow. We managed to develop a highly collaborative workflow in which we would get all of us would get together and design through charrettes, and that was where the majority of the design came from. And then we would break out and produce. So it really created an equal sense of ownership, and it worked really well for when we entered quarantine. Another thing was integrating systems from the beginning. We knew that we wanted to combine passive and active systems so that sustainable design could be accessible as well as attractive. And then we want to remember to play. It's very important that I think that students stay positive and have a place where they can still be children, and while also learning about these sort of intense, giant problems we face. Kept us motivated too.
That's fantastic. Well, thanks to both of you. We appreciate you guys presenting with us and connecting with us today. That was super inspirational.
Thanks so much.
All right. So we are on to our last presentation today. Last but not least, we have our division winner for the attached housing division and our grand winners for the residential category. Team 2 Attached from Miami University with their design, the Peace Village. Tim Sperling and Taylor Lure, hope I got that right, probably didn't, of the team will be, okay, good, I got a thumbs up there, will be presenting today. So it looks like you guys are on. It looks like we have the slides pulled up, so that's great. Can we hear both of you?
Hello.
Hello. All right, so yeah, we're ready to rock and roll here. All right, well, we are ready when you are, so just say the word and Amanda will get started.
Yeah, we are all set for you whenever you're ready to get us started. So my name is Tim Sperling. I'm a fourth-year architecture student with a sustainability minor.
Hi, I am Taylor Lure. I'm also a fourth-year architecture student with a minor in geography.
And we are just extremely grateful to have the opportunity to present our work at this year's EBA Virtual Summit and represent our team, which included 10 students as well as faculty and industry partners.
Our project is situated in Over the Rhine, a historic neighborhood of Cincinnati. We have a long-standing relationship to this community formed by Tom Dutton, a former Miami professor. He developed the Center for Community Engagement and has taught countless students that architecture truly has the power to change people's lives for the better.
Our site, Main and Schiller, already has this impact on the community. Children and their families see this as a safe outdoor space that shouldn't be bulldozed by developers. It was clear from a local survey of residents that they favored keeping the existing basketball courts, garden, and green spaces, and desired low-cost housing on the site. These community needs were the driving force behind the development of our project, Peace Village.
The integrity of Main and Schiller has only been strengthened by our design. All existing elements have been left completely intact and enhanced by new community spaces. The switchback path attaches the basketball courts to the homes. The entry stoops offer opportunity for interaction between residents, and the mural corner is a gathering space featuring connections to community artwork.
So we've created a series of design goals that Peace Village has achieved, and we will use these goals to structure the remainder of our presentation today. As you can see here, there are neighborhood cohesiveness, accessibility and inclusion, sustainable community, prefabricated design, and passive house and net zero design. Taylor will now highlight how we have addressed the first of these goals.
Over the Rhine is known for its large body of historic Italianate architecture. Building here presents a challenge as there are numerous conservation guidelines that must be met. Our project took this into account by composing the facade in terms of massing, using community-inspired materials, and creating a contemporary take on traditional facade symmetry.
You can see how our design incorporates the tactics that Taylor just mentioned, but these tactics are not the only way that Peace Village is directly connected to the community. Smaller scope aspects within Main and Schiller tie the residents together, such as a mural corner found in the existing Permagenic garden, which was then imposed on all unit facades and referenced in the mural corner on our site.
To make Peace Village physically accessible, we placed our 2 accessible units on the south end of the site, which is at the bottom of the hill and closest to the parking, which provides the easiest access to these homes. There's also an accessible path that leads to all of the units whose interiors have been carefully considered to follow ADA guidelines. And then in terms of financial inclusivity, our project has been designed for those living under a 50% area median income. This qualifies Peace Village for low-income housing tax credits, which help fund the construction of the homes and reduce overall costs for residents. Our homes have a slightly higher upfront cost than typical construction, but our passive house strategies reduce long-term costs.
So our third design goal is centered around the idea of sustainable community. As I mentioned earlier, we knew that the courts would be essential to sustaining the culture and happiness of the community because they have fought the constant effort by developers to gentrify this neighborhood. They advocate for doing development differently, an idea that we believe Peace Village has fully embodied.
Creating plentiful green spaces across the site is one way that this project illustrates this concept. These spaces not only make the site more enjoyable for the community, but also act as a cohesive water management system. Bioswales, permeable pavement, and a stormwater collection system all work in unison to naturally drain and filter water.
Moving on to our fourth design goal. Our fourth design goal is to use prefabricated design methods. BuildSmart provides us with building envelope systems that include custom prefabricated panels constructed off-site to mitigate factors such as cost, energy use, and construction time. For the exterior, our project uses the E-wall that incorporates all control layers into one system that is all designed to Passive House building standards. Efficiency is furthermore increased with the interior modularity of the unit types. In the diagram shown on the screen, you can see the 3-bedroom unit broken down into its modular components. Each unit consists of 2 primary modules, the residential core seen on the right and the internal circulation seen on the left. This setup dramatically reduces building costs and overall construction time for the project.
The interior design of the units was influenced greatly by the context we were working in. For the first floor living spaces, the 2 dominant design ideas were 1, reflecting the site's strong diagonal axis, and 2, translating the site's tiered zones of privacy and function into a delineating mode at the interior scale.
There were many strategies that we employed to ensure that the indoor environment was comfortable and healthy for Peace Village residents. First, materials were carefully selected with environmental quality in mind. Second, the homes can be naturally conditioned using cross ventilation. And lastly, unwanted noise was reduced through the use of a resilient channel, thick walls, and a carefully selected material palette.
We saved the best design goal for last, and that is using Passive House and net zero practices throughout our project. Peace Village reduces site energy consumption by incorporating several smart technologies that can be monitored through our Peace Village app. This digital space will keep the residents connected, and this is especially relevant today during times of social distancing.
We have used several tools to determine our energy consumption and its impacts on our site. Woofy Passive allowed us to meet Passive House standards and reach source zero energy. Safera measured impacts on heating and cooling in our initial planning stages, and life cycle analysis outlined our project's minimal global warming potential. All Peace Village homes also meet Passive House 2018 standards that were developed not only to reduce energy consumption on site, but also at the source. By integrating its 5 core principles into our project, we will achieve not only net zero, but source zero as well. We believe that Peace Village will serve as an example of how affordable housing can lead a larger movement towards reducing overall source energy consumption.
While Passive House minimizes the need for energy-controlled systems, renewable energy is used to fulfill any additional demand. A photovoltaic microgrid collects energy from the units and links them to a shared storage system. This allows for excess energy to be sent back to the grid, and then financial savings are split evenly between the homes. The narration you've just heard was not fabricated for the sake of the Solar Decathlon competition. It is a real story with real people and real threats to their community. Recently, there's been talk that the city is slating Main and Schiller to go back out for bidding, which could be the turning point for the long-term growth of this community.
Just want to finish up by saying that some members of the team, myself included, have decided to conduct an independent studio at Over the Rhine this fall, which will allow us to gain more firsthand experience with community members and hopefully push this project to actually be built in the future. Residents of Over the Rhine have been silenced for too long, and now it's time for their voices to finally be heard. Thank you.
Fantastic. Taylor, Tim, that was a great presentation. It's no wonder why you guys were the grand winners for the residential category. That was fantastic. We have a minute or two. We're a little bit over, but we have a minute or two, I think, for questions. So question for you, why did you guys choose to get involved with the Solar Decathlon?
Yeah, I can take that question. Our school, Miami, has been really involved in passive design and sustainability for the last couple of years. We have a professor who was actually our studio professor for this project who promotes this competition that we've been in the past 4 years throughout the department. So myself and another student from the other Miami team ended up doing the independent study in the fall to kind of prepare for this. And then we sort of promoted it to all our other classmates and just really wanted to get involved in bringing sustainability up to the mainstream of design.
Well, we're glad you got involved, that's for sure.
Thank you, guys.
So another question here. So how can other young designers like yourselves encourage people to be more conscious and follow this path of energy efficient design and help, move the effort to make this become more of a standard procedure across the industry?
Yeah, Taylor, do you want to talk about that a little bit?
Yeah, of course. I think you can really encourage students to get really involved with this, especially I know in school with every project we're given. I know at the beginning, they kind of made it a secondary thing. They're like, well, you do the design and then maybe afterwards look at how you can make it more environmental. I think education needs to be altered to where that is like one of the first things you think of when you're designing, and then it just become habit for designers to do that.
Yeah, absolutely. Thank you. Well, thanks again, Tim and Taylor. I think we should all give a round of applause for all of our student presenters today. You guys made this look easy again. I think I can speak for everyone in saying that you all continue to inspire us and inspire the whole industry with your innovative approaches and the wide variety of building types and climate zones and everything. Yeah, right. I'm right there with Gene. And with that, we are going to wrap it up here. I don't know, Gene, if you have any last words, but I know we here as Solar Decathlon organizers just hope you reach out and see how you can get involved. And yeah, thanks again to all our speakers.
Well, I'd just like to thank all of the students. This was a project for last year, and this was sort of extra work with no extra credit to come in and make this presentation this fall. So grateful to each of the students and the great projects. And I encourage my fellow builders to engage with this whole competition, because I've hired 2 people out of this competition and almost hired another one who's on the screen, I believe, but Amanda and I carried on quite a conversation after her stint as a competitor. So thank you so much, Zach, Amanda, all of the student competition team, Rachel, everyone involved at NREL, and so happy to see this a major part of the EBA Summit.
Yeah, thank you, everyone. That was fantastic. I do want to encourage you. One of our big pushes in partnership with DOE and NREL and Solar Decathlon has been workforce development. We're significantly short in the industry on employees. So Nancy and I and Brooke have created a job posting and job seeker site on the Whova app. So we would love for you students, especially those of you in your senior year, if you would like to go there and post a resume under the job seeker, I think we'll get a lot. Nancy, what are we up to for attendees now at the summit? Did we hit 400?
Very close to 400, yeah.
Yeah. So we've got about 400 attendees at the summit, but we really want to encourage that interplay between some of the top builders and really in the world and all of you great students that bring such incredible ideas. And I love the app. Jean and I talk all the time about apps. And it looked like you guys just, in a week came up with an app that runs the whole community. So there's some digital natives in the group too that we need. So thank you again, everyone. Have a great weekend. And we thank you for being a part of the EBA Virtual Summit.
Thank you all.